Hi everyone, welcome to today's webinar on underground storage tanks, what the regulatory requirements mean for your UST. We're glad you could join us. My name is James. I manage our webinars and events here at Triumvirate, and I'll be your moderator for today's event. Before we get started, I'd like to provide a brief overview on what the webinar is going to entail as we run through a few housekeeping items, and this should all be pretty familiar for those of you who have attended some of these in the past. So you'll note here that all lines are muted. You won't be able to use the hand raise functionality to verbally ask questions, but you can use the questions tab over on the right-hand side of your screen. So feel free at any point throughout the webinar to type in a question, and at the end of the presentation, I'll moderate those questions for our speaker, and we'll get to as many as we can. There will be a couple of polls throughout the webinar, so please participate in those. And as well, as I alluded to, the last 15 to 20 minutes will be spent and dedicated to questions. So please submit your questions prior to that and during, and any we don't get to, we'll make sure we follow up with you following the webinar in the coming days. Finally, please stick around till the end, as we'll be announcing an offer to help assess your UST and determine whether removal is necessary, and we'll help provide some advice as to how you can go about doing that. So please stick around for that. I'm pleased to introduce our speaker today, Kevin Coulon. Kevin's the Regional Services Director for Field Services and our industrial niche at Triumvirate Environmental's New England branch. In this role, he manages wastewater department, routine field service decontamination, and on-site support. He also manages our emergency response program for New England, overseeing all programs and responses. He's also been involved in dozens of tank inspections and removals, so he's very familiar with the content that he's presenting on today. Kevin holds a BA and a BS in Science Geography from Bridgewater State College. With that, I will turn the controls over to Kevin. Hey, Kevin.
Thanks, James. So today's presentation, as you mentioned, is about understanding the regulations for a UST, with our key message being to understand the requirements that come with having a UST on your property. We're hoping that today you can understand some of the regulations behind it, some of the inspections that go with it, and what you should look at in regards to your UST, if it meets the regulations or if you should look at potential replacement or removal. So who is this presentation for? This is really for EHS managers, facility managers, property managers, and in some cases you may be all three. You may be an EHS manager and a facilities manager, or you're renting space that's owned by a property manager and you have to work with them in regards to any USTs you may have on your property. What you're going to learn today is how the regulations have changed, what's happened over the years. We're going to talk about some UST inspection requirements, and then also how to remove a UST and what goes into removing a UST, all the steps that need to be taken, and what happens after you pull the UST out of the ground. Is there any other steps that happen beyond that? We're going to cover all that as an overview. This is only an hour long, but we'll get through it as much and give you as much information as possible through this presentation. Before we get started, just want to poll the audience to see where everybody's at, but what is your greatest challenge regarding USTs on your property?
And you'll see the options there. We just launched the poll. Anything from you're unfamiliar with the regulations, unsure of how and what to inspect, not sure if we even have a UST, and other. So please respond to that, and we will share the results. All right, Kevin, we got most of our responses here. We'll push out the results. As you can see, we have 33% who are unfamiliar with the regulations. So I think we're right on track with the content here today.
Thanks, James. So thank you, everybody, for answering that question. And to go over what we'll be doing today from an agenda standpoint is we're going to give an overview of what a UST is and what regulations, where to find the regulations under that cover USTs. From there, we'll move into monitoring and testing the USTs, and then into closure and removal of UST. And at the end, we'll do a quick summary and open it up to questions and answers. So with the first one being UST overview and regulations, first question that comes up is, what is a UST? So the exact definition as defined by the 40 CFR, which is in section 280 of the CFR in subtitle I, an underground storage tank is a tank system, including its piping, that has at least 10% of its volume underground. Now you may be thinking you only need 10% of your tank and the piping underground, but it's very rare that you come across a tank that's only 10% underground that's considered a UST. Most underground storage tanks that you see now, you don't see. They're underground, they're under a concrete pad, and you usually just see the two manhole covers at the top that are going to access the ports at the top of the tank. But you do have a picture here that shows what an underground storage tank may look like, and you do have your two access points at the top. 100% of this tank is underground, and also the piping is underground. What you may see in addition from that is a vent line or a fill line that's coming up above the ground that may be away from where you have your underground storage tank. It's all dependent on how it was designed. Where you find all the regulations for the federal UST program, like I said, Subtitle I standards, and these are found in 40 CFR 280. You're going to find both the technical and also the state program approval is under CFR 280. In addition to that, part of what's being stored in the underground storage tanks falls under some other RCRA regulations, which fall under 40 CFR in sections 260, 61, 62, 65, and then you also find them in 70 and 71. And Subtitle C is in a change, it's more of an amendment to those regulations. So it's not changing those sections, just amending them. What we've also put in here is we've put this website that you can click into, and this is the EPA's website for underground storage tanks, which is a very helpful website, and I can stay on this slide for a second if people want to jot this down. But if you go on and you click on EPA's website under USTs, it's going to bring you to their underground storage tank regulations. And from here, you can go into everything you may have additional questions on, direct from the regulation. There's 2015 revised underground storage tank regulations. It talks about what's new from the federal government, talks about cleaning up releases, preventing and detecting releases, how to meet the UST requirements, which will go much more in depth into meeting those requirements, and then learning about a UST. So it gives you a full introduction of an underground storage tank. This is a good website if you have time to play around with the website, go through it. There's a lot of information that could be very helpful. From a compliance schedule, from the federal side, there was a phase-in of release detection for all existing tanks over a 5-year period, according to the age of the tank. And this was all done between 1989 and 1993. So at that time, there was leniency as to when you needed to phase this into your systems. On December 22nd of 1990, they added release detection to pressurized product piping systems. So if you had a pressurized product, they wanted to see release detection not just on the tank but also on the piping. And then in December 22nd, 1998, it was the issue to upgrade or replace as per new standards within 10 years. So there were some tanks that needed to be upgraded. They didn't meet the specific requirements that they want to replace within 10 years, so by 2008. From a state level, the states have gone past those regulations and they've made it more stringent. So there's a couple that are up here. The state of Massachusetts has issued a compliance state for the removal of all single-walled USTs. So if it's a single-wall UST, it's an unlined single-walled UST, they want it removed by August 7th, 2017. So if you're a Massachusetts agency, you have a single-wall tank, you're coming up on your fiscal year, it's time to start looking at, now you got to look at August 7th, 2017. Same thing goes for Rhode Island. Rhode Island has a compliance date for the removal of all single-wall tanks by December 22nd, 2017. The other state, which is it's odd that it's lenient because the state of California will regulate the water that comes out of your faucet. They have decided to have a removal of all single wall USTs by December 31st, 2025. So if you're on the line and you're in California, you can sit back for 8 years after Rhode Island and Mass and then start working on removing your single wall. Another state that's not up here because they've already gone past their time is the state of Connecticut. They issued that any tank prior to install by 1989 needed to be removed within 20 years. So in Connecticut, they had the limit of 2009. So when the new changes came into play in 1989, if you didn't update it by that time, you had 20 years. So by 2009, they were all pulled. Under the regulations, there's inspection requirements. USTs that have not been inspected since 1998 had to be inspected initially within 2 years of the federal energy bill, which was put in place in August 2007. So that gave you from 2007 to 2009 to do an initial inspection. There was also periodic inspections that needed to occur every 3 years thereafter, with an initial being done by August 8, 2010. So as you can see, as the dates came on, more and more regulations were coming about in regards to inspections, which the inspection was a preventative maintenance in order to prevent a spill to the environment or to groundwater. The minimum, the periodic inspections for every 3 years was a minimum requirement. And then they also issued that it must be inspected by an EPA inspector, a state agency inspector, or an inspector or contractor that's designated by the state, or a private inspector operating under a third-party inspection program. And that would be paid by the owner or the operator. This is often referred to as an AV operator. The AV operator is going to be overseeing the tanks. It may also have an operator on site that works under them to do tank inspections or do the routine inspections. There's also leak detection that would need to happen on a monthly basis. So leak detection testing would be every month. That's also by your AV operator. Currently, right now, we're doing AV operator inspections for a few clients that call in because there's testing that has to go in to become an AV operator. Not all companies want to become an AV operator, but there are options to do AV operator inspections through a third party. The regulations also set forth some requirements for the tanks. If it was single-walled, it needed to be corrosion-resistant single-wall tank. It would also need to have spill and overfill protection. So this prevention is for the transfer hose disconnection spills. This is often where you get a spill above ground and they want to see a catchment basin. So if you have any material that's left in your tank while filling the underground storage tank or the lines coming into it, this would be caught and it wouldn't become a spill. They also want to see overfill prevention. And this is either an auto shutoff at 95% or the operator gets an alert when the UST is 90% full. It lets them know that you're getting to your limit. You don't want to be putting anything more in the tank. It also requires release detection and proper installation standards. Now EPA is going to have their own installation standards, but EPA, as we talked about under Subtitle I, gives the states their own authority to make it more stringent. So some states may require different inspections, may require different installation. Maybe they want a poly tank as opposed to a steel tank. So each state will differ slightly. We talked about the federal requirements and are there any exclusions? And in most regulations there usually are some exclusions that you don't fall under these regs. So a few that are out there is if you have a farm or a residential tank of less than 1,100 gallons or less that has a capacity for storing motor fuel for non-commercial purposes. So if you have motor fuel and you're using it for farm equipment or residential equipment, that doesn't fall under the UST regulations. Or if it's a tank storing oil for consumptive use on the premises where it's stored. So if it's consumptive, you don't fall under this. If it's a storage tank underground, then you would fall under the regs. The other one that's excluded is septic tanks. And pipeline facilities, including the gathering lines, those are regulated under Natural Gas Pipeline Safety Act of 1968, as well as the Hazardous Liquid Pipeline Act. Now, these aren't covered under the UST regulations because they're already covered under two separate acts. So by having this coverage by the other two acts, they don't need to, the EPA didn't need to issue anything in regards to this for underground storage tanks. The other ones that aren't covered are service impoundments, pits, ponds, and lagoons. Now, just those words themselves, those are holes in the ground. They're not fully covered. A couple others that are out there are stormwater or wastewater collection systems. This could be an oil water separator. This could be a wastewater tank that's underground. Flow-through process tanks. This would be a grease interceptor. So if you had a grease trap outside of your building, there are some cases where you may find a 3,000-gallon grease interceptor. Those aren't covered under the underground storage tank regs. Liquid traps or associated gathering lines directly related to oil or gas production are not covered. And then storage tanks situated or on or above the floor of underground areas such as a basement or a cellar. So if you're a facility and you have a 10,000-gallon tank that's storing all of your backup diesel, you're on natural gas, but you keep 10,000 gallons of backup diesel, and you may be thinking, well, my tank is technically underground, but I can access my tank through my basement. It's a vaulted tank that you can walk into the vault, and it's not an underground storage tank. However, what you may fall under there is now you may be under SPCC regulations because you're going to be above the 1,320-gallon capacity for an above-ground storage tank, and now you're under SPCC regulations, which are separate from the underground storage tank regs. Some provisions that were issued under Subtitle I. Provision 9002, it states that the owner must notify the state of a UST existence. Now, there are situations that have come up where people don't know they have an underground storage tank. It was about six to 8 months ago, we got a phone call from a client that was putting in a steam line. And as they're digging for the steam line, they came across an underground storage tank. It was an unknown underground storage tank that was found. Well, the state needed to be notified. So the whole process went through what we're going to be talking about today, and that tank was removed. A couple of weeks later, another phone call came in, and 2 more were found. So there are situations where USTs are not known that they're in the ground. Maybe it was sold, maybe it was there were no plans for it, but if you do find them, you have to notify the state of the existence. There's also provision 9003. So EPA regulates applicable. The EPA regulations are applicable to all owners. This includes the design, the construction, the installation, and the compatibility standards for new tanks. It also talks about the leak detection, the record keeping, reporting, and closure. So this has to do with the install and the upkeep of your tanks, and also what you need to do if you had to remove it. Under that same provision, under 9003 subpart H, it gives the states the authority to clean up petroleum releases, or they can require the owner-operator to do so. So this gives some power to the states to require that it has to be cleaned out. And then the next provision, which is 9004, gives the states the ability to implement stricter regulations. Now, we talked earlier about the deadlines by the states about removing their single-wall tanks. Those states implemented that they wanted them out. So that's a quick overview of the regulations and what's a UST. Now, we can't go completely into the regulations because we could spend probably an hour just on the regulation. But we're going to go into some of the monitoring and the testing that goes with the underground storage tanks that you may have on your facility. But what I'd first like to ask is, how often do you inspect your UST?
And the options we have here should be up on your screen. Anything from quarterly, monthly, every 3 years, when there's a problem, or never. And we'll wait just a few seconds for everybody to respond to that. Okay, great. So we'll share the results. Kevin, we have 60% are doing monthly inspections. That's great. And then 24 every 3 years, 16% quarterly.
So from a good news is that most people are doing inspections. Whether some people are doing the monthly, the 3-year, there is a 3-year requirement for most tanks. But as we go through this, you may see that maybe if you're only doing it 3 years, you may also need to do it monthly. So the reason why we do these inspections is to help prevent the release of material. And honestly, most releases that come from a tank is actually from the piping and not the tank itself. It's either through spilling, it could be from overfilling, it could be corrosion of the piping, it could be a loose fitting, maybe at a 90-degree on the piping. And that's where you see most of your releases that are going to come from an underground storage tank. This was going back a couple of years, more 4 or 5 years ago, we had a client that had an underground storage tank that actually had the piping running through the foundation of their building. And when they went to go do their tightness testing, they failed. And as they did more testing and they followed the line, they found that 200 feet down the piping, they actually had a crack in one of the seals, and it was releasing diesel fuel. They were seeing that their diesel was constantly going down, and it was more than what they were using. And it actually required blocking off the main entrance to their facility, cutting open the floor, removing the pipe, excavating some of the soil, and then putting in new pieces of pipe and making sure that it kept a seal and they didn't have any additional leaks moving forward. Now that was one that was very sensitive because it was in the main lobby of their facility, but it does happen. You could have a connection where you either get corrosion or it was poor workmanship that putting it together that allowed for a leak. There are other issues. There could be natural events, or there could be accidents. Maybe you have a rupture in a tank or a natural event. We mentioned California earlier, potential for an earthquake that could rupture or move tanks or move the piping that comes off of it. Tank tightness testing is often done to ensure that you're not going to have a leak. And 25% of UST systems are found to be non-tight when testing under today's standards. Of those 25% of USTs that fail, it's 84% of those are often because of faulty piping or a loose tank fitting. A picture on the left, it's not actually the piping from an underground storage tank, but if you look at this piping, you have multiple joints that come through. And if your piping comes off your UST and makes multiple 90 degrees, each 90 degree you may have a potential issue. You have a connection, you could have corrosion, you could have poor workmanship, but you want to make sure that what's being put in is top quality so you're not going to have a release down the road. For pre-existing tanks, most existing tanks they're bare steel, and these date back before 1998. Some new tanks that are coming out, some new technologies, you could have an STIP3. It's an industry standard, and this is going to have an electrical isolation. So for the ones that are 10,000 gallons or fewer, they're going to have an anode at each end of the tank, where this is an electrical charge that they're testing to see if there's any leak. It's also going to have protective coating, and it has cathodic protection. And the cathodic protection, most of these tanks are usually going to have an electrical line that's coming up, usually a green electrical line, that's going to come up one of the risers. And one of the risers is going to be one of the pipes coming out. And that's where you're going to connect to it, and you're actually going to do an electrical test to see if there's a leak that can be detected in the area. The other side of doing the electrical, which has a little bit more engineering into it, is you could do, outside of doing the more engineered STIP3, is a fiberglass reinforced plastic tank. These are double wall plastic tanks, and there are a lot of facilities that some are switching over to the plastic, some are switching over to the electrical isolation for the STIP3 type tanks. Once you have your tank in, then you have to do your monitoring and your leak requirements. This is going to be your leak detection, it's going to be corrosion protection, and spill and overfill prevention. Now, this all goes into the monitoring, so in spill and overfill prevention, this may be under your, if you're under an SPCC plan, most of them talk about procedures that you need to take when filling either an above ground storage tank or an underground storage tank. Those filling requirements under those regulations and those plans usually require that you have someone from your facility that's present while filling operations are happening. Now, in some cases, that isn't always the case. We've had multiple responses we've gone to where this wasn't followed, and a company comes up, they don't know the procedures, they fill, have an overflow, and the overflow could either be small or it could be large. We've had one large one that we worked with a client for almost 4 months to do a full cleanup. And then you have some small ones where it could be an overflow, but then it goes down into a basement because the tank is right next to the entranceway to a building. Having this overflow prevention, it's going to prevent an emergency response. Doing the leak detection is going to prevent having to do remediation of soil if you ever have to pull that tank. Now, if you do detect that there's a leak, well, you have an issue with your tank and you may either need to repair or replace. From leak detection, there are 3 choices. The first one is doing monthly monitoring. So monthly monitoring of leak detection. Second one is monthly inventory control and 5-year tank tightness testing on tanks with overfill and corrosion protection. This was only until 1998 or for 10-year-old tanks. And then there's also monthly inventory control and annual tank tightness testing. This was only also until 1998. Some alternatives that are out there for doing leak detection is inventory reconciliation. So if you're looking at your tank, if you get a readout, you're going to see you have 2,000 gallons in your 10,000 gallon underground storage tank. You do another inventory, you see that you have 1,900 gallons in your 10,000 gallon tank. Well, you look to see how much you used. If you used 100 gallons, then that's where that 100 went. Now, if you didn't use any of the material in your tank and you're down 100 gallons, you may have a leak. There's also automatic tank gauging, which is also an acronym used ATG. A common one that's out there is a Veeder-Root system. That's going to give you an active readout of what's in your tank. You can have subsurface monitoring for vapor and groundwater, and then interstitial monitoring off double-wall tank systems and secondary containment. So if your tank is double-walled, you may have some sensors inside that second wall of the tank to see if you have any material in it. Or if it's inside of a secondary containment, so you have a single wall tank inside of a secondary vault, you may have some electrodes in there to let you know if you have any leaks into that vault. This next slide just shows what a Veeder-Root system is. So if you're walking through a facility, you don't know that you have a UST and you see a Veeder-Root on the wall, ask the question as to what it reads to, because this will be reading from an underground storage tank, and it's going to give you an accuracy of 0.2 gallons per hour of what's inside your tank. And this is going to allow for monthly inventory control, and it allows you to see what is in your tank at any given time. There's a test, there's also a printout, and it'll give you everything that's in there. The other side to the Veeder-Root is these also need to be calibrated. So one thing to think about, if you're going to go this route and use an automatic tank gauging system, you need to calibrate them at least annually to make sure that it's reading properly. And then the other one that's out there is a continuous statistical leak detection. These are often found in places like gas stations or in a place where you want to have an uninterrupted business for 24 hours. So if you have a 24-hour station or around-the-clock fueling operation, this is going to be your best bet. It's continually running a leak test every 24 hours, and this meets the federal and state requirements for monthly monitoring. It makes it very easy. It's continually looking at your tank, and it's going to let you know your fuel height, your temperature during the idle times, and it doesn't slow down your operation. If you do go into a gas station, next time you go to fill up your car, if you notice the two large manhole covers, those are your access points to the tanks. If you look around them, you may see these monitoring wells. These monitoring wells are used to do vapor and groundwater monitoring. This is going to allow to see if there's any contamination in the groundwater or if there's any vapors that are found in these monitoring wells. If you do find anything in there, you may have an issue. You could potentially have a leak. Now, these are in the backfill area, and they're also as close to the tank as possible. The backfill is often called the overburden, which is put on top of the tank. Now, we did talk about the STI P3 tanks and how they could have cathodic protection. Now, these are usually galvanized, and they use a sacrificial anode, and it's an electrical charge. So to do this, sometimes you could see that there is a junction box to circulate current. You can go right to the junction box. That's where you may find your hookup, or as we said before, you may see an electrical line that's coming up one of the pipes that you can connect to. Now, this test must be done every 3 years. It must be tested every 3 years. Well, that gives you an overview of the different types of monitoring, the time frame for when you have to do the monitoring, and what type of testing you could do on your underground storage tank. It is an overview. If you do have any questions, you can definitely pose them at the end of the presentation. But the next is, what happens when this doesn't work and you need to do a closure and removal of a tank, or you're going to be doing an upgrade of a tank? What do you have to do for your current underground storage tank? So the closure by removal takes a good amount of preparation. First preparation is going to be financial preparation. Do you have the money set aside to do that in your fiscal year? Or if you're in Massachusetts or Rhode Island or California and you have time, do you work to get this into your next year's fiscal year? You would also have to submit a closure request to your state, and it's a closure request and you're submitting the plan to the regulatory agency. The plan is often written by either a licensed site professional, a licensed environmental professional, or your state is going to let you know what type of person is going to have to submit this and sign off on it. In Massachusetts, it's an LSP. In Connecticut, it's an LEP. Along with submitting a plan, you're also going to have to put together a health and safety plan for the removal of the tank. You're also going to have to think about calling DigSafe. One thing to know about DigSafe is most DigSafes aren't going to mark out all the water lines. Depending on which town you're in or which DigSafe you're going to call. In most of New England, all the states except for Connecticut, you can go through regular DigSafe. Connecticut has their own DigSafe line. And with DigSafe, you have to keep in mind that you usually need between 48 and 72 hours notice that you're going to be opening the ground for them to come out and mark it out. And you'll start to see markings for gas and electrical, but not always will you see water. You sometimes have to call your own water authority. You have to look at electrical. Do you have a system that has electricity running through it? Or we walked a underground storage tank that's going to be coming out in a couple months that actually had light poles. And the light poles were right next to where the underground storage tank is. And when you're looking at your footprint for the underground storage tank, that's just right above the tank. So when you start to pull that out, you have to worry about the electrical, the light post that's next to it. So you may have to cut that electrical off and remove the light post. Or in that same case, there was a tall tree. What type of vegetation or landscape needs to be removed because it's going to be undermined. Also have to set up barricades. So you're going to have to set up temporary fencing to keep people out. In Massachusetts, when you open the ground and you have a trench, we have what's called Jackie's Law. And that was put in place from a few years ago when there was actually a trench and a small child got into the trench and it ended up being catastrophic, where they developed Jackie's Law that pushes to have these barricades and to block an open hole, whether you cover it with a plate or you do temporary fencing. Now, when you're opening the ground, you have to think about permits. Now, to remove a tank, you're going to have to obtain a fire permit. Fire department's most likely going to come out when you pull the tank to ensure that it's clean, and they're signing off on the tank. And then you may also need a trench permit. The definition of a trench is that it's deeper than it is wide. Now, are all holes that you pull a tank out of, are they going to be considered a trench? It's a gray area, whether it's yes or no, but your town may require you to pull a trench permit for it. And then the other thing to think about is shoring. Shoring, or you're going to need a trench box. So you're going to have to get into the hole. Now, shoring you may be doing because you have a foundation that's nearby, and you're doing that to help with the integrity of the foundation. The trench box is going to be there so you can safely enter, and that's going to cover you from your State Department of Public Health, and it's also State Department of Public Safety, as well as OSHA standards. You're also going to have to talk about, as I mentioned before, the LSP or LEP, or there's some states that it's an LESP, but they're going to oversee and collect the samples, and they're going to ensure that the closure plan is met. So that way they can sign off on it, and it can be submitted to the state that you've removed it, and it's put back to its normal state. You've done your backfill, and you've restored the ground back to where it was. So there's a closure that can be done by removal of the tank, which is going to require cleaning the tank prior to pulling it. Now, the first two that are up there, the dry ice procedure or the nitrogen purge, this has to do, you often use this when you're removing a gasoline tank. So if you have to enter a gasoline tank, you're going to have a flammable atmosphere. The use of nitrogen and dry ice, if you put dry ice in there, dry ice displaces oxygen. So any oxygen that's in there will be displaced, and you no longer have a flammable atmosphere. The one downside of doing this is now you're entering under air because your oxygen levels are not going to be high enough to safely put someone in that area, in the tank. You could do cleaning using water rinsing, or a Venturi purge. A Venturi purge has to do with an explosive atmosphere, and this includes using two different fans, where you have one fan that's pulling out the explosive atmosphere while you have another fan that's pushing in fresh air. And this is a way of purging to remove any explosive atmosphere so you can safely enter the tank. You could also triple rinse the tank. You could do chemical cleaning. One form of chemical cleaning is if you have a 6-oil tank. 6-oil is very hard to clean. 6-oil could be stuck to the sides of the wall, and you may introduce number 2-oil into it, because 2-oil can cut 6-oil. They'll put it to a liquid, and you can remove it and clean the tank that way. The cleaning of the 6-oil using a 2-oil usually requires the entry. If you have to enter into an underground storage tank, this is a confined space entry. You're now under the confined space regs under OSHA, which is going to require having a trained rescue person, having trained entrance. You're going to have somebody who's going to be collecting the air readings. You'll be at least using a floor gas meter to ensure that the atmosphere is allowable for someone to enter. You're going to have rescue equipment like a tripod and a rescue winch. And you're going to have somebody entering either using an APR or using an SCBA. They're going to do their cleaning, and then you're going to pull them out. They're always going to be attached to that lifeline so you can get them out in case of an emergency. Along with cleaning the tank, you also have to worry about cleaning the lines that come off of the tank. You often have 3 different lines. You have a feed line, so what does the tank go to? You have the fill line from your fill port, and then you're also going to have a vent line that's going to be removed and cleaned. The other thing to worry about when you're doing this cleaning and the removal is, as in the picture on the left, what if you run across groundwater? The groundwater will also need to be tested and collected to see if there were any issues. Now, if groundwater is not part of the plan, you've already done testing of the ground or core samples and the groundwater is clean, you may just be pulling the tank and then you're going to backfill. In most cases with groundwater, in our experience, we backfill with stone. till you get to a flat area, and then you're backfilling with the rest of the overburden in clean soil. So how do you get the tank once it's been cleaned? Now you're doing a closure by removal. You need to access the tank. So to access the tank, if there's a concrete cap, you're going to be breaking up the concrete. You store the concrete in one pile. Then you're going to excavate the overburden, so the material that's on top of the tank, to gain access to the top entryway to the tank. You're going to collect the overburden in one pile. The overburden in most cases is in its own stockpile because it's usually considered clean. It's on top of the tank. It's most likely not contaminated. You're then going to dismantle accessible piping and ancillary equipment that's attached to the tank. That could be the Vita root system, or it could be a connection for a cathodic testing. And then using proper equipment, such as the excavator that's pictured, you're going to remove that underground storage tank. Most times when you remove it, the fire department is there to observe the removal, as well as your LSP or your LEP. And in some cases, the excavator may not be the right size. Maybe you need a crane that needs to come out to site because you have a 30,000 gallon UST that you need to remove. Once the tank is removed, it's cleaned, it's going to be tagged and labeled as a clean tank. When you send it off to your scrap yard, they're going to want to see your fire permit that's been signed off on and see the tag that it's been cleaned. Now, any holes that were in the tank from the cleaning process, you want to plug the openings except for the 1/8 inch vent line. This shows that the tank has been fully cleaned. There's nothing else that can get into it. If you have a tank that's sitting out there and has a hole and it rains, now you have a filled tank with water. And then you also inspect the tank and the piping to ensure that it's clean, it's not contaminated, and you can send it off to your tank yard. If you do find that you had a leak, and this is through confirmatory testing, that now you have to excavate the soil around the tank. And this is usually 1 to 2 feet both around and above the tank. In some cases, depending on how severe the release was, you may have to go farther. We just did a tank removal where the original hole was 8 feet deep by 5 feet wide. And as testing was done, it quickly got to 10 feet deep by 10 feet wide. So it doubled the width but only increased 2 feet at the bottom. But that had to do with what was contaminated. So it could get much larger. The soil will need to be sampled, and you'd want to consider doing a fast turnaround. Standard turnaround is 5 days. It's standard pricing with analytical labs, but you can also do 72-hour, which is usually 50%, or 24-hour, which is usually 100% the cost of standard, but you limit the liability with having an open hole or having a plated hole, or you have a trench that's protected by temporary fencing. Any soil that comes out that's contaminated is going to be disposed of according to its contamination, or if testing shows that it's actually clean, you could use that, if the plan allows, as backfill. Now, you pull the tank, so you're going to have a large void. You're going to have to truck in additional clean fill. A clean fill, you could either get a certification from the facility that it's coming from that it's clean, or you could run your own analytical to ensure that it's clean fill. The other way of closure is considered closure in place. Now, this is only recommended if removal is not an option. And by removal is not an option is it could affect the structure of the building. So if your UST is underneath your facility, well, you can't remove it because you'll affect the structure of your building, so you could close in place. However, if you ever take down that building, you also need to budget in, you're now going to have to remove that underground storage tank. How to backfill a tank in place is using an inert material like concrete or an approved polyfoam material. If you have a tank less than 1,000 gallons, you could fill it with pea gravel. You could use slurry, or in the case that we had, this was 1.5 years ago, we got a call from a client that had took down a building. They were digging for the new foundation. They came across a 6,000 gallon UST. It was filled with sand. Now, as we started to remove the sand, we noticed that the sand was covered in oil. So the closure wasn't followed properly. It was just filled with sand, and it still had material in it. So all of that sand that was pulled out had to go out as petroleum-impacted sand. We removed the tank and come to find out that the material underneath was also contaminated. So you want to make sure that who you're hiring to do this or who you're hiring to write the plan is actually ensuring that the plan is being followed out properly. So we've covered a lot, and just to summarize everything that we have covered, our key message by covering the closure and removal, monitoring and testing, the overview of UST and regulations is to help understand the requirements that come with having an underground storage tank on your property. In summary, the things that we hope that you can take away from this is to help find out if your tank is state or federally regulated. If you have a tank that's for consumptive use, you're not regulated under this. If you're a residential that you have a tank outside that's used for motor fuel, you're not regulated. Your grease trap is not regulated. Know your state's UST testing requirements. Is it monthly? Is it quarterly? Is it every 3 years? Is it every 5 years? Hopefully you can understand that there's a process for removing an underground storage tank. It's not as easy as digging it up and pulling the tank. There's reporting that has to go to the state, and there's notification. And also knowing who needs to be involved and what each individual's role is. So is the DEP involved? Is the EPA involved? Is an LSP involved or an LEP involved? And are you bringing in an outside contractor to do the removal? So it was a lot. I hope that this helped. And at this point, I would like to open it up for questions. We have about 10 minutes remaining. So if anybody does have any questions, please feel free to ask.
Thanks, Kevin. We do have a few questions that have come in, 3 or 4 so far. Like Kevin said, we've got about 10 minutes or so. So if you have a question, get it in, and we'll get to as many as we can. To start, David asks a question, and this actually came in early in the presentation. I think it's more of a clarifying question, but what is an AV operator? I think, if I'm not mistaken, you meant AB operator?
Yes, an AB operator is a certification. So when you're doing inspections on a tank, there's different levels. You have the AB operator, which is certified by the state to do the inspection, and then you may have a C operator. The C operator isn't exactly certified, but they're doing the inspections under the direction of the AB operator. So it's, the title is an AB operator, but it's a certification that's given out to the person that can oversee the inspections and the monthly monitoring of the tanks.
Thanks. And the next one is about inspections. Do I need training to inspect a UST?
Yes, depending on what your plan covers. So if you are a facility that's under an SPCC program, well, if you're already under an SPCC, your USTs are going to be covered under that. And part of an SPCC program requires that you'll train the individuals on the plan and how to operate under the plan. Now, if you're not under an SPCC program, but you are covered under state or federal UST program, if you're doing the inspection, you do need to be trained on how to inspect that. You may not be the AB operator who's doing the full inspection, but you're now what's considered the C operator, and you're under the direction, you've been given training in order what to look for and how to do the inspection, and what you should see that isn't correct to call your AB operator.
Toby wants to know if a decontaminated UST can be left in the ground.
Depending on your state, yes, and well, depending on the state, yes. So we did a project for a client that had the funding to do the cleaning, but because of the requirements, now this was in Massachusetts, it was a single wall tank, did the cleaning, left it in place, and inerted the tank. But now there's a requirement that it needs to be removed by a certain time frame. So since Massachusetts, before August 7th, 2017, that tank can stay in the ground and it's cleaned. So the removal process is going to be a little bit easier. You don't have to do the cleaning of the tank. But it would depend on which state you're in and the requirements, and depending on what type of tank you currently have.
So what about upgrading? When is it beneficial to upgrade or maybe replace a UST? Is that a viable option?
Replacement or upgrade is going to be based on, first it'll be based on your budget, which one's going to work best. You know, if you have a tank that you find an issue with and it's a 2-year-old tank, it may be worth trying just to fix or upgrade the tank. If you have a tank that's 18 years old and you find an issue with it, it's probably worth spending, and allocating the funds to do a full removal and replacement. If you have a single wall tank that doesn't meet the regulations and you don't have leak detection or you don't have corrosion detection or corrosion prevention, then it's in your best interest to do a replacement. Mm-hmm. But if you don't have the ability to do the replacement, it may be lining the tank, or it may be cleaning it, putting it offline, and removing it, a year or two down the road. What some people have also done with their underground storage tanks is they've looked at the risk of having an underground storage tank as opposed to an above ground storage tank, and opted to do the removal and replacement with an above ground. The above ground, you can see the issues. If you have an issue with the tank, it's a little bit easier to access it. But it comes down to preference, and it also comes down to what the funding is that you have for that project.
Thanks, Kevin. That takes care of the few that were just submitted. We'll announce our last call now for questions and move on to our last slide. We could start to wrap things up, let you know what you should expect tomorrow. We're going to send you an email with a few different resources. You'll get a copy of the presentation, so I hope you weren't feverishly taking notes. You're going to get the presentation. We're going to send you a link to the recording so you can view and listen to this at your convenience. We'll also send you a short survey. Let us know what you thought. We're doing these webinars pretty frequently and do take your feedback seriously, so let us know if there's something else that you're looking for from a topical standpoint or formatting. Feel free to share that. Finally, I did mention earlier that we'd be making a special offer at the end of the webinar. And as Kevin outlined today, tank removals can be pretty complex and time-consuming. You want to have the right people, the right equipment to make sure that you're compliant and safe. So I encourage you to visit this link, jot it down, copy and paste into a web browser, and what you'll find is an offer for a free initial assessment. This consists of an on-site meeting just to discuss the characteristics of your UST, size, location, contents, to understand what you have, and then a review of your compliance records and any past inspections. Finally, we'll help prepare a plan for removal if it's necessary, and possibly a more in-depth inspection. So if you're interested in that, there's a form on the page. You can also send us your phone number using the questions box here, and I'll make sure that somebody reaches out to talk to you. And you'll also find Kevin's email address. So if a question pops up at the end of this webinar, feel free to send him an email, and I'm sure he'll be happy to respond. And that pretty much covers it. In addition to our tank services, some of you who aren't as familiar with us, you'll find that we provide hazardous waste disposal, emergency response, which Kevin manages, lab moves, among other EHS services. So we hope we'll be able to work with you in the future. I don't think we got any other questions, so I think it's safe to start to wrap up. Kevin, do you have anything to add before we close down?
Just if people have time and they want to get some more knowledge in regards to the EPA regulations, the website, as you're going to be getting the presentation sent to you, please take a look at the website. There's a lot of good information that'll help answer some questions. If you run across any questions you find while reading through the regs, please feel free to reach out to us so we can help you through it.
Excellent. Thank you, Kevin, for sharing your knowledge and expertise with us. Really appreciate the information. And I hope everybody learned something new and is taking something away from the webinar today. And let us know if we can be of any help. That concludes today's webinar. Please expect that email tomorrow, and we appreciate your participation and your questions. Thanks, everyone. Take care.